Hello and good morning. We're in October and this is week 6 and this should be on the back. Make sure you have week 6 real big. Okay. We may have one more test this marking period before the end. Let's take a look here. What does complementary mean? Actually, this class has a test on Monday. So tomorrow you should have a practice test. Chapter 2. Okay, so I'll put something together today. Complementary means two angles that add up to 90 degrees. So two angles that add up to 90 degrees. Superman, supplementary, adds up to 180 degrees. Make sure you know that. All right. We're going to skip 2.6 for now. Copy these down on a new sheet of paper. Well, let's take a look at these. There's one rule that you need to know. If you multiply or divide by a negative number, you change the direction of the inequality. Okay? We'll talk about that in a minute. So put a star by that. Draw a line. Okay? You have x's on this side, x's on this side. You want to subtract x from both sides because that's smaller, so that's x plus 5 is greater than. Remember, the open side means greater, okay? So greater than negative 4. And now you want to subtract 4, and you're going to get x, or rather subtract 5. So you're going to get x is greater than negative 9. Let's take a look at the graph on that. So let's say this is 0. And without counting, let's say that's negative 9. Put an open circle. Since there's no line under here, it's greater, so it goes this way. Do not color the circle in. This one will be colored. Watch. Another way to do that is like this. Either way. Okay. This one right here, draw a line. You want to get rid of this 5 by subtracting 5 from both sides. So you're going to get negative 3x is less than or equal to 9, I think that is. And then here you're dividing by a negative 3. As soon as you divide, change the sign, flip it. Okay? So this cancels. So now you're going to get x is now greater than or equal to 1 negative, it's going to be a negative 3. Let's take a look at that graph. Let's say this is 0, and let's say this is negative 3 without counting. Put a circle. Since there's a line under here, you would color it in. And then it says bigger, because it's open, goes this way. Okay, one more. This one is similar to one you had, I think it was number 7 the other day. So it's 1/3 times x, and then it's 1/3 times 6 over 1. And then minus 4 over 3x, and then minus, actually that's going to be a double negative, so that's going to be plus 4 over 3 times 9 over 1. Let's take a look at that. 3 goes into 3 once, 3 goes into 6, 2. So I'm going to end up with 1/3 x plus 2 minus 4/3 x. This 3 goes into 3 once, 3 goes into 9, 3 times 4 is 12. Okay, now you have x's. The other day I didn't combine these, but we're going to. You have the same denominator. A negative 4 plus 1 is going to be a negative 3 over 3x, which gives you a negative 1x, which some kids just write it as negative x. I would too. This right here is plus 14, and you're done. Make sure you understand that. Again, that was like number 7 the other day. And here's your work for today. Okay, if you get stuck, let me know. Make sure you check your answers. I'll look around, believe it or not, and I see who's actually looking in the back of the book for answers. Let's look here. Okay, we're into geometry now. Let's talk about the bell work here. Geometry is 438. Okay. So, the rules. When you reflect over the x, you change the y value. This one, when you reflect over the y, you change the x values. This one, when you reflect over x, you switch them. In this one, you switch and change. Two things here when it's a negative x. All right, I want you to graph these lines. Let's take a look at them. Y equals x. That one looks like this, a 45 in the positive direction. This one is a negative x, so this one is backwards. Make sure you know that. Y equals negative 3. Here's my y. So go down 1, 2, 3. This one should look like the x. Okay, if it says y, it's flat like the x. There it is. X equals negative 3. This one, there's my x. 1, 2, 3. This one looks like the y. And there's the answer. Y equals 0 is a special case. Here's my y. And its 0 is here. So it's got to be this flat line. So y equals 0 is the x-axis. Make sure you know that. Okay. Let's see what's going on here. On a new sheet of paper, try these. All right, if you reflect it over the x, you change the y. So it's going to be negative 2 and negative 4, 6 and 5. Because when you change that, it becomes a positive. When you reflect over the negative x, you switch and change. So SC, switch them and change. So this one comes first, and that's going to change to a negative. This one comes last, and it changes to a positive. This one comes first. This one comes last. Make sure you know your rules, okay? When you reflect over the y, you change the x. So here is my x. So that becomes 2 and 4. Change this one, negative 6 and negative 5. You change only the x. Which one is the pre-image? The pre-image is the original. That's your pre-image. Make sure you know that. Do you know what the other ones are called? The other ones are called the image. Okay, let's talk about the new section 3.2. Copy down everything you see. All right, a reflection is a flip. That's a flip. Okay, so if I take this and I flip it, that's a reflection. If I slide it, that's a translation. Okay? So let's talk about that. Today we're talking about translations, which is a sliding. The property, and this is number 1 in your workbook, when you slide something, the original stays the same. In other words, if it's a triangle this big and you slide it, it's still going to be a triangle this big. Okay? It's not going to shrink. All right? So the property of a translation is it stays the same. Same thing with the reflection. It stays the same. I mean, this, if I flip it, it's still the same thing. It's just flipped over. Okay? So a translation is the same way. The property is it stays the same. Okay? So if it's an angle of 20 degrees, let's say, and I slide it, it's still going to be an angle of 20 degrees. So that's the property, and that's number 1. Number 2, or this one right here, it says reflect over the y-axis, number 1, and then reflect it over the x-axis. Well, if you reflect it over the y, which is this way, it's going sideways, so it's going to change the x. Sideways movement changes the x. So the new point, or reflection on this one, is going to look something like this. So the new point is going to be over 3 up 4, and then this one is going to be 5 up 1, over 5 up 1. Okay? And then if you flip it over the x-axis, then you change the y. So this one is going to look something like this when you reflect it over. Now I'm not going to actually graph it, but this one is going to become, here is the x, so you're going to change the y. So it's going to be over 3, but down 4. And this one, when you flip it over the x, it changes the y, so that's going to be over 5, down 1. And there it is. That's called a composite, where you reflect it once and then reflect it again. Okay, it's a composite. All right, but we're talking about translations now, so I just want to clean up some stuff here. Is this a translation? Well, let's take a look now. I got to go back to my diagram somewhere. See if I can figure out where I did it. All right, I did it right here. Okay. So the question here is it a translation? Let's see. Well, think about that. Yeah, I could take this and slide it over here. So I'm going to say yes. This one is not a translation. So if I slide this over here, that's not a translation. But if I double flip it, it is a translation. If I single flip it, it's not a translation because it changed position. Well, let's take a look at this one. This one is a translation, and here are the rules. The translation is your x, you're going to add a -2. So if you put a -2 there, the new point is going to be, the translation is going to be 6 minus 2, that's going to be 4. And then this one is a 4, so you're going to put a 4 minus 2 is 2. Okay, so if you slide this one over to the left, 2, and then up 4, that's where it would be. Let's take a look at that. Let's just check it. So over 6, 1, 2, 3, 4, 5, 6, down 2. Okay, so this is the original, called the pre-image. Okay, now here we want to slide it to the left 2, according to this. So slide it to the left, 1, 2. Slide it to the left 2, and then go up 4. So 1, 2, 3, 4 is here. So the new point should be here, and it looks right. The answer is over 4 up 2, and that's what we have. Okay? So here you're taking a point, you're sliding it to the left, which essentially you're adding a negative to it. Okay? Or in this case, we're subtracting. And that's 4 minus 2. So it's real easy. All you do is put those in there. Try this one. I want you to translate it. You don't have to graph it. Okay, so we're going to the left, 1, and then up 4. So you're going to put a -1 here and a +4 here. So the new point, okay, called the image, is going to be 6 minus 1 is going to be 5, or the location is 5 and 0. And we could graph it to verify it. Might as well. Over 6, 1, 2, 3, 4, 5, 6, down 4. That's the original point. We're going to the left 1, so 1 space this way, and then we're going up 4. So 1, 2, 3, 4 should be here, and it should be over 5 up 0. 1, 2, 3, 4, 5 up 0. Bam. It's right. Okay, real easy, not hard. Remember, a translation is a sliding. Okay, now this one is a thought problem here. Copy this down. So we have the final one here, over 3. 1, 2, 3, down 1. This is the answer. Okay, this is the image. Okay, what was it before we slid it to the left 2 and up 7? What would it have been? Can you figure out where it was? Okay. So we went to the left 2, so that means we'd have to go to the right 2. That's what I'm thinking. We'd have to do the opposite. And then we went up 7, so in order to get the original, we'd have to go down 7. So I'm going to say it's somewhere up in here. But here's how you do it without a graph. Well, in order for it to be a +3 when I added a -2, it would have to be 5. Because 5 minus 2 gives me 3. And then a -1, it would have to be a -8. A -8 plus 7 is going to give me a -1. So the original point is over 5 down 8. Look at my diagram. 1, 2, 3, 4, 5, down 8. I bet you that's right. Okay, so that's a tricky one. They're asking you to think backwards. What would it be where I subtracted 2? So what minus 2 equals 3? That's basically what you're doing. So you could say x, and then you could solve it. You could do +2 and get x equals 5. On the next one, it would be what plus 7 is equal to a -1. You could put an x. You could subtract 7 and get negative 8. Or you can do it in your head. Either way. All right. One more. Number 11 in the workbook. Now, you don't have to get your workbook. I got mine right here. Okay. Let's take a look at number 11. Now, this one right here, it says, Hugo graphed the triangle, this triangle here, and then he reflected it over T, and then he translated it. So he reflected it, and then he slid it. And he reflected it over this line here. The equation of the line is y equals 2. Let's take a look at that. Y is right here, so y equals 2 would be this line. Now let's think about this. If he reflects it first over this line, then it would flip something like this. It would look something like that if he reflected it. And then if he slid it over 3 and up 1, over 3 would be this way and up 1, it would look something like this. Okay? Now that's close to what he has, but I think you'd have to slide it up more and over more. And so that's, I'm going to say his is a mistake. All right? All right, now let's move on. This is called a composite. Copy this down. A composite, you just combine these, real simple. So the real one, or the composite of these two, would be a negative 4 plus 3 is a negative 1. And then this one and this one would be a negative 2. Okay, so you just add up your x's and then add up your y's. Real simple. Okay, so your assignment for today is right here. If you need help, ask. All right, good luck and have a good morning.